Today, we will talk about programming, because programming is not only learning commands that you need to type. Programming is an art. It's like if you want to paint, it's not only you know how to take a brush and put some ink on it and draw on a canvas. It is an art. So we need to show you the meaning of a programming. So what is a programming? A programming is a creative process. And also we can learn programming by discovering techniques, either sometimes from the first person or from others. Like if you want to learn painting, either you can be creative and try to invent some new techniques in painting, or you can learn from others. If you want to draw shadow, then maybe professional people can teach you how to draw shadows. And then maybe you can then later invent your own ways of drawing shadows. The techniques that we are going to provide for programming can be applicable to any programming language, including Java. So programming is like a concept that is universal, not related to any not related to any programming language. Programming involves three entities. I call them entities because I cannot say three people, because the programmer is a person, user is a person, but the computer is a machine. So we say three entities. The picture you have in front of you, here on the left we have the programmer, on the right we have the computer, and we have the user. Programming or writing a program goes into stages, marahil. First, the programmer has to design the program, and this is what you will do in this course. You will write a program in Java, and the program or the instructions that you write, you are writing the program to the computer. You are telling the computer what to do. So the program is instructing the computer for following commands to solve a certain problem. After the computer receives the instructions, then it will interact with the user for doing the calculations. As an example, the calculator you have at your hand, if it is, for example, Casio, then the company Casio has programmers. So they write the program, they put this program on the calculator, and then they sell it to customers. Now, when you buy this calculator, you use the calculator, then you will become the user, because the calculator is the computer now running the program, and you are the user who is utilizing this device. You are the user. So see the arrows? It means that if the computer needs data from the user, it will tell the user, I need a data from you. And when the user needs to give data to the computer, it gives data to the computer. So data going out from the computer to the user will be output, and data going from the user to the computer will be input. What is an algorithm? An algorithm is a word that was the twisted word for the ancient clerk Abu al-Haytham al-Khwarizmi, Muhammad al-Khwarizmi, I think this is his right name. So al-Khwarizmi is like, algorithm is like a twisted word from this clerk last name. So what is it in fact? An algorithm. An algorithm is a set of instructions for solving a problem. So if you want to solve a problem, then you have to put the steps for solving this problem. Putting these steps for solving the problem, the whole together, the steps is called an algorithm. An algorithm must be expressed completely and precisely. So you have to write in details what are the steps in the algorithm. So if you want to solve a problem, then you put those solutions of this problem in steps. Step number 1, do this. Step number 2, do this, and etc. Algorithms are usually expressed in English, and I will show you an example. When we want to write, let's say, a program for adding 2 numbers, first we write the algorithm, we write the steps, how the computer is going to add 2 numbers. So you can express it in English, or there is a special code that can be used called a pseudocode. A pseudo means not real code. So instead of writing everything in English. We pick some words for some steps. Once the algorithm is defined, then you can express this algorithm into Java easily. So the converting will be like each step you have in the algorithm, you can see how you can convert it into Java. Let me give you some examples on algorithms. And you know that algorithms, or sometimes we always use it in our life. For example, when you buy a table, okay, you go, for example, to IKEA or IKEA, and you buy a table. Now the table does not come assembled to you. مو بمركبة إلك. You have to assemble it by yourself. So how to assemble this table? Usually they put a guide inside. It's called instruction manual. See the word instruction manual. This manual tells you how to assemble the table. So how the manual is written? Usually it is written in steps. They tell you step number 1, do this. Step number 2, do this, and until the whole table is assembled. In fact, the instruction manual is an algorithm, because there are instructions inside for assembling the table. So the problem that we want to solve, here it says solving a problem. So the problem we want to solve is in fact assembling the table. Another example, if you want to prepare, let's say, a recipe, طبخة, okay? So if you want to cook a recipe and you don't know how to cook this recipe, for example, you want to prepare a small cake, so, and you don't know how to bake this cake. So what you do, you open a book on cooking and try to pick the one that suits your taste, and then you read how it is prepared. In fact, the instructions written in this book are, or it is an algorithm. So they tell you first you do this, second you do this, third you do this, until you completely prepare your cake or bake your cake. And maybe I should give you another also third example. If someone stops you outside in the road and asks you for a certain direction. So I know that Google can help you on this, but sometimes people ask you, where can I go, for example, to city center? Now, when you explain the direction to this person, you are explaining the direction in steps. One step should follow the other one. Now, what you are expressing is in fact an algorithm, because you are given instructions to that person to follow to get to city center. So this is basically what does it mean by algorithms. And when you convert algorithms into let's say a language, a programming language, then it is called a program. So algorithm steps, you write them for solving a problem, let's say in English or pseudocode. And when you convert these steps into a programming language like Java, Python, then it is called a computer program. Testing and debugging. These also some words, you will find them quite even in programming. When we say testing, when you write a program, don't expect that your program will be correct the first time when you run it. So when you run your program, probably you have errors. And again, we will explain the type of errors. But when we say testing, it means if you design a program, you need to run it and test its results. Is it given right answers or is it given wrong answers? And if it gives wrong answers, then you need to correct the program to give right answers. Debugging. And you know the word bug, what does it mean? Bug, it means hashara, but here it doesn't mean a computer bug, by the way. So debugging, when you have an error in a program, this error is called a bug. So sometimes when your program, you download an application and you double click on this application for running and it gives you wrong answer. And when it gives you wrong answer, people say this program has a bug. A bug, it means it has errors. This is why it's given wrong answers. So to correct these bugs, the word is debugging. So debugging is a technique used for spotting your errors. And you will see it a lot in the menu of the compiler. So testing and debugging eliminate errors, يتخلص من errors by avoiding them in the first place. Carefully design classes, algorithms, and methods, and you have to be carefully code everything into Java. So if you want to test your program, you need to test for some cases. You run your program. Let's say if you design a program to add, subtract, and multiply two numbers. Then when you run your program, then you have to test it that your program is adding correctly. You run it again to test it that it is subtracting correctly. And also you need to run it again that it multiplies two numbers correctly. So you make cases for your input to test your program. And if there are, why we do this? To discover and fix any errors we have in our programs. Errors. There are three kinds of errors. Go down here. See, it says there are three kinds of errors: syntax errors, runtime errors, and logical errors. Now, if you remember, we said that the grammar of the language was called syntax. قواعد اللغة, programming language, is called syntax. And if you don't follow the syntax correctly, you will get errors. It's like, for example, in Java, if you want to write an instruction, command, amr, you have to put semicolon at the end. Now, if you don't put semicolon at the end, this will be violating the rule of the language, the syntax of the language, and the compiler will tell you that you have a syntax error. So syntax errors can be corrected in early stages of your program. So when you write your program, you cannot run your program without correcting the errors. Now, runtime and logical errors, they happen while the program is running. I'll give you two scenarios. You downloaded an application on your mobile. While the program is running, all of a sudden it goes out. And maybe it happens to you, to some applications. Now, this error is called runtime error. It stops your program. Your program cannot continue anymore. So it's called runtime error. Run, it means during execution, and runtime errors. Now, logical errors, on the other hand, it happens while your program also is running. But what is the logical errors? The logical errors that your program is not given correct errors, but it does not stop. Runtime errors, your program stops completely. But logical errors, your program continues, but it does not give right answers. It's like you write a program to add two numbers. You give input 2 and you give input 3. Now you expect the answer to be 5, but your program is given 6. So your program does not have syntax errors, does not have runtime errors, but it has logical errors because it does not give correct answers. So what is syntax errors? They are grammatical mistakes in a program. The grammatical rules for writing a program are very strict. Now, when we say very strict, it means that the computer cannot understand half mistake of the syntax. For example, if you say in English, he are running, you know, grammatically is incorrect. You should say he is running. But people can understand when you say that let's say he break, okay, the chair. People can understand, although the right grammar, he breaks the wall or the chair. So in English or in any human language, small mistakes can be tolerable, مسموح فيها, and you can understand. But in computer programs, it is very strict. For a command, if you just make one change of a letter of this command, then the computer will say that I don't understand it. For example, when you say public, P-U-B-L-I-C, suppose instead of P, you write B. So now it becomes completely different word. The computer will say, I don't understand this word. So it is very strict. Compilers, they catch syntax errors and it prints an error message on the screen. And we will see that also. And it will happen with me also. When I run a program, sometimes by mistake, I do something, syntax errors. When I run the program, then I discover, oh, I forgot to do this, and we correct the error. And we will see some examples. Some examples using a period, which is dot, where a program expects a comma. So instead of writing comma, like semicolon or comma, you put dot. Then the compiler will not understand what you are doing. It will give you syntax error. Like what we have done, what we have explained before, runtime errors that are detected تكتشف when your program is running, while your program is running, but not during compilation, not in the beginning. It will pass testing for syntax errors. When the computer detects an error, it terminates, stops the program, and it prints an error message. Some programs do not print error messages. All of a sudden, it goes out from the memory. As an example, try to attempting to divide by 0. To some programs, dividing by 0 does not stop the program. It just gives you wrong answer. It becomes logical error. Finally, logical errors that are not detected during compilation or while running, but which cause the program to produce incorrect results. And this is sometimes, this one is one of the difficult errors that programmers try to find. Your program is given wrong answers, but from where? So you have to put some statements, some commands in your program to show exactly where it is given wrong answers. Example, an attempt, محاولة, to calculate a Fahrenheit temperature from Celsius temperature by multiplying by 9/5 and adding 23 instead of 32. So when you write the equation for converting a temperature from Fahrenheit to temperature, you should multiply the temperature by 9/5 and add 32. But by mistake, you add 23, so you get wrong answers, and this becomes a logical error.